I'm very pleased that today to introduce Professor Frank Tompa from the University of Waterloo. Professor Tompa has done many outstanding contributions in the area of database management systems and also in security. So today we'll talk about access control.
Thank you very much. So thank you for inviting me here today, and I'm happy to talk to you. I want to talk about a couple of simple ideas that can help build a flexible system for access control. This work was done with a former PhD student of mine, Amir Shinai. The background for this work is to think about organizations that have lots of different needs for their security purposes, and a variety of things like you've probably heard about open and closed policies for whether or not people normally would get access or normally would be denied access, and how to administer the access control. So who is it that has the right to access, and who is it that determines who else has the right to access the data? And this changes from organization to organization, but software developers want to build one piece of code and sell it to multiple organizations. So how do you build code that you can deploy in multiple places and have different policies being used at each one of the various installations? So first of all, this is what I'm going to assume the customer environment looks like, and the customer environment I'm going to assume is using discretionary access control. That is where people explicitly grant or revoke access to data from other people. So you pass the possibility of accessing your data, whether it's to read or write or update or compute a sum or whatever it is, you pass this information from one person to another. I'm going to assume that the subjects, the users, are organized into a hierarchical setting that might form a group hierarchy. So individuals belong to groups, groups can also belong to other groups, and this can form any kind of an acyclic structure that you wish. And if a group is authenticated to execute some particular operation on some data, then every member of that group is able to do that, and it goes down through the group hierarchy. Similarly, I'll assume that there is an object hierarchy, so the data itself is also organized hierarchically, and again, if you have the rights to access a large object, then you have the rights to access all the pieces of the object in general, and we're going to then refine it to go to a more fine-grained access control that says, well, we want to permit or deny access to pieces of the object, and we want to allow that from not necessarily everybody in the group, but we may want to deny it from some of the subgroups of the group too. And the privileges that we have are assumed to be available for each method that you have on the object. So let's just, for simplicity, let's think of this as an object database, and so every object has a pile of methods that can be used on that object. And for every one of that methods, either you have the privilege to execute that method or you do not have the privilege to execute that method on that object. Privileges themselves, as I said, have to be administered. So somehow we have to figure out who gets the right to grant the privileges to other people, and how does this all work together? Well, the groups and the group hierarchy are themselves objects. So they are also stored in the system. So we're going to use the same access control mechanism to control the groups, who are the members of the groups, and what are the privileges that are assigned to the various groups. We will assume that that's controlled by the same access control mechanism that is controlling all other objects. Similarly, the data about the users themselves, including the users and the user group hierarchy formation, is also governed by the same access control system. So everything is controlled by the same access control mechanism, and the groups are, the hierarchy for the groups is not necessarily the identical hierarchy to the group objects thought of in the object hierarchy. That is, the inheritance of who gets permissions does not necessarily follow down the group hierarchy, but they themselves, the group hierarchy is superimposed on the object hierarchy, which represents the groups themselves. Okay. None of that is particularly important. It's just that to get a sense of where it is that we're trying to operate. I'm going to also assume that we have the possibility of parameterized privileges. That is, rather than saying that every patient has the right to read every medical record, you want to control it so that, in general, patients have the right to read their own medical records, but not other medical records. So we do that by having some sort of a parameter or attribute that we're going to attach to the permission. And we can, for that attribute-based access, we can use any of the information at our disposal. We can use the object type, the object ID, any of the component values, the subject values, or any other user values, what group you're in. We can use the environment variables such as time, location. So any of these things can be used to control, to parameterize when I say that this group can access this class of objects, that I can now parameterize it to say, well, this group, as long as these other attributes hold, can access objects in this category as long as these other attributes hold on those objects, so that we can match specific things. And it helps avoid the explosion of explicit access privileges that you'd have to write down if you didn't have this kind of parameterization. I'm also going to assume that privileges can be either positive or negative. That is, either I can explicitly permit somebody to execute a particular method, or I can also explicitly say that somebody is not allowed to execute a particular method. Okay, so we're going to have both positive and negative privileges. Now, let's get to the next bit, which is distinguishing between the privileges that are assigned by the administrators versus the privileges that are inherited through the two hierarchies. Again, we have the group hierarchy, subject hierarchy, and we have the object hierarchy, and we've got inherited privileges. So members in the group hierarchy, as I said, can inherit all of the privileges for whatever group they're in, recursively. And on the object side, privileges on objects may also be applied to all of the sub-objects. This has led to some people saying that we don't need to actually represent the hierarchy the way I've drawn it in this diagram. For example, maybe I can remove the redundant edges so that I have, for example, because this group has this group and this, let's say, individual as a member, as two different members, then what happened? Any privileges assigned to this group are also assigned to both of these. But similarly, every privilege assigned to this group is also assigned to this individual. So I really don't need this edge in between to get the same privileges being passed down throughout here. So I could conceivably get rid of those two edges and say they're completely redundant. They don't actually give me any extra privileges. And this kind of suggestion has been made by many people, saying we're going to make sure that whenever we talk about privileges, we'll always talk about the reduced set of privileges and get rid of all of the transitive edges. But I will argue that that's not a good thing to do. Consider the following. I'm going to add an edge to my group hierarchy, which now gives me privileges that would be inherited around the left-hand side. Now when I delete that edge, the system will have to automatically insert another edge that says, well, you deleted the membership of this subject in this group, but the privileges should still be inherited from all of the other higher groups because, after all, the privileges used to come from all of those groups. And in fact, distinguishing between these two cases, do I mean to only remove you from the immediate group you're in or from all of the groups that are in the hierarchic system is a problem. It's ambiguous as it sits right now. And maybe I only want to delete you from another one. But what I really don't like about this particular setup is that adding an edge followed by deleting an edge doesn't give you back the graph that you had before, generally. And it would seem to me that it's very difficult to administer this group hierarchy if simple properties such as addition followed by deletion doesn't give you back the same graph. So if I accidentally put something in and I take it out, I've got to worry about what side effects there might have been. Therefore, that's not the way that I think that we should be representing these hierarchies. Instead, we should record the explicit permissions and the explicit hierarchy, and then we compute at runtime the effective permissions using the inheritance through the hierarchies. Okay? If you, for some reason, don't want to do all that computation all the time, then you can use something like a materialized view. You can compute the effective permissions and then choose to store that. But remember that you are storing a view of what the data looks like, and therefore if you update the original data, you have to adjust your view to reflect the updated data. But now, as I insert and delete edges, I will exactly have the property that I want. I insert an edge, I delete an edge, what's left are exactly the edges that were explicitly recorded. So I'm going to here insist that we have some explicit hierarchy and explicit permissions, and then we have the derived effective permissions, and I'll keep those two things separated. And as I say, for performance, if you want to have better performance for calculating, is this person allowed to access that particular object? Well, you can always create some sort of a materialized view. You can calculate that and store it and refer to that. Just make sure you keep it properly up to date. Okay, so now we've got the two parts, the explicit permissions and the effective permissions. This is just an explanation of what can change the effective permission. So what do you have to worry about? Well, I can add or delete members to a group, as the picture that I was showing. That's going to change my effective permissions. I can grant and revoke a particular group's privileges. I can create and destroy groups. I can alter the authorization to group mapping. So when you sign on, I forgot to say it, it was on the slide. When you sign onto the system and you're about to start, the authorization mechanism, using your password, using whatever credentials you present, can initially assign you to some of these groups, some of these subject bubbles that I've indicated, and then those are the ones for whom the effective permissions are available to you, are applicable to you. So, we want to be able to manipulate all of these things, and the question is, where do we get the permission to manipulate all of these things, to manipulate the groups, to manipulate the permissions in the groups, to manipulate the authorization, which groups you can assign to initially, to create and to destroy groups. Well, if somebody has the permission, then they could give me that permission. So if I have the permission to add and delete members for a particular group, I could conceivably grant such permission. I might have the permission to grant the permission, and I could then grant the permission to somebody else. But going backwards, how does the first person get the permission to do things in order to be able to grant things? What I'm going to recommend here, and again, a fairly simple idea, but I think it captures what we want to do and to make a flexible system. The initial privileges for any particular object will be established whenever that object is created, and we call this creation time policy. So we're going to write down a mechanism whereby whenever an object is created, the initial privileges on that object get stuck into the matrix, into the access control system. The permissions get set appropriately. That includes when I create a group, the permissions on manipulating that group are going to be put into the system. When I create a user, the manipulation of the attributes of that user will again be put somewhere. Who's allowed to do what kind of manipulation on that user object? Okay, so for every object that I create, at the time of creation, the access control is initialized for that particular object. And we don't need a privilege to do that initialization. That is, it is the system itself that's going to do it, that's going to do that as a sign of the permission. So the question now is, how do we set that up? Remember, what we're trying to do is have one piece of software here that can be used in many different kinds of environments. So how do we set that up? And the intention is that at every installation of my system, of my software, we're going to specify what the creation time rules are, and we'll call that the creation time policy. Here are some examples of the kinds of initial conditions, the creation time privileges that you might want. When a travel form is created, you might want to grant permission to the financial officer to read it and to create a payment request. And so as soon as the travel form gets created, those permissions get assigned in the right places. And you might also want to deny permission for the financial officer to create a payment request for himself or herself. So again, that happens, that's a policy that you'd have to somehow capture, and you'd capture it as a specification of what to do when a travel form is created. Similarly, when a group is created, we might want to grant permission to the creator to add members to that group. When a consent form for a medical record is created, we might want to grant permission to the hospital administrators to grant read permission for that medical record to others, etc. This is the kind of thing you would do. So what kind of creation time privileges might we have? Well, we're eventually going to have this reliance on the inheritance. And remember, I talked about having parameterized systems. So we can also grant some privileges when we create a type rather than when we create the object itself. A type is in some senses just another kind of an object. So when we create a particular data type, I've called it here D-type, then we can assign a privilege to a group. And whenever we have instances created, maybe we don't have to assign any particular privileges for those. They'll only get the inherited permissions. But what will be the inherited permissions? I will have, at the time that I create the type, I will specify that the ID of the user has to match one of the fields in the data type that I've just created. So by using a parameterized type, a parameterized permission at the time that I create the type, then I don't necessarily have to create permissions every time I create an object of that type. Okay, so at deployment time or even later, so I said we could establish these creation time policies whenever we initially create the object, whenever we initially install the system, but in fact, there's no reason why you couldn't also update it later and change the policies later. But the important part is I don't want to establish these policies before I've deployed the system. I don't want to put it into sort of at system creation time. I don't want to hardwire it into the system because I want to be able to change it for every installation of the system. So the kinds of rules that I might want for setting creation time policy, I might want to have a group called a super user group. And I might want to assign all permissions initially. Whenever any kind of an object is created, all methods on that object have the privilege in the super user group. And then it's up to the super user to then assign the privileges appropriately. Or I might want to say that whoever the creator of the object is initially gets all of the permissions on that object. Or an object type definition can include the creation time privileges for object of that type, as I just showed you an example. These are things that you can specify as a creation time policy, and then they will be implemented when the system is deployed. All other manipulation of the explicit permissions, so other than the creation time permissions, all other manipulation of explicit privileges is always done by people who have permission to do it. That is, in order to grant, you need permission to grant. In order to read, you need permission to read. In order to revoke, you need permission to revoke. So for every one of these possible operations that you might want to do, then you have to have the permission to do that. And so in some senses, it's a little bit like a differential equation. Once you set up the initial conditions for the initial trajectory for the whatever it is that you're sending out off into space, the spit bomb or spitball that you're going to throw. Once you have the initial direction and the initial velocity set up, everything else follows from there. Okay, it's all controlled by the way you've initialized it. Same thing here. All the permissions that you could eventually end up having in the system are all dictated by exactly how you've set up those initial permissions. If you don't give anybody the possibility of granting permissions, of granting a permission to delete an object to somebody else, then nobody else will ever get such a permission from you. Okay, so that's all I wanted to say about the explicit permissions. Now let's talk, and for the rest of the talk, I'll talk about the implicit permissions instead, the effective permissions, the ones that are derived from other permissions. How do we determine what are the effective permissions when we have the hierarchy and we have the explicit permissions all set up? The model that I find easiest to think about is thinking about an explicit protection matrix that you've probably heard about before. So for every subject, every object, every operation, I have either there's a permit, or there's a deny, or there's nil. That is, I haven't told you whether it's permit or deny. This is what the explicit matrix looks like. As well as having that explicit matrix, I also have the subject hierarchy and the object hierarchy, and in some installations, some setups, there would also be an operation hierarchy. If you have the permission to grant permission on read, you must also have the read permission yourself. If you have the permission to read a particular object, you must have permission to also execute method 3 to sum up all of the values of that object, something like that. So there could be a hierarchy also among the operations. What we need to do now in order to calculate the effective privileges is we have to understand what is the default rule. So if I've got nil somewhere, I don't tell you a permission, what are you going to use? If the whole matrix is completely empty, if nobody has permissions to do anything, who's allowed to, if nobody is explicitly permitted to do something, everybody is left blank, what is it that you're going to do? Are you going to allow it or are you going to deny it? So at default, I need some sort of inheritance rules, and I need some sort of conflict resolution rules. That if I somehow work out under one path that you do have permission and under another path that you don't have permission, the question is, how do I resolve that conflict? Do I, at the end, grant you the permission, or do I deny the permission? This is what we're going to look at for the rest of this talk. And it's really extending some work that was done by Jajodia and others, and more than 10 years ago now. Okay, so here is an example. I've got, it's the same diagram I had before. I have a group hierarchy, and I have an object hierarchy over here, and I have some explicit permissions. And I'm not going to worry about at the moment what the particular method is, but let's just say for some method, this subject or group has permission to do that operation on this object, and this one has permission to do it on this object, has denied permission to do it on this object. This one has a positive permission to do it on this object. This one has a positive permission to do it on this object. And the question is, at the end, if this subject wishes to execute that method on this object, do I allow it or do I deny it? Which one should it be? First of all, this edge is completely irrelevant to making the decision, because we're assuming that privileges are inherited down the hierarchy, but not up the hierarchy. So this edge is completely irrelevant to the decision of whether or not the circled subject has permission on the circled object. Next thing is that there is a path here. This subject is a member of this group. This group is denied privilege on this object, and this is a sub-object of that object. So it would seem that this should therefore deny permission. On the other hand, this subject is a member of this group. This group is allowed to do the operation on this object, and this is a sub-object. The target object is a sub-object of that object too. We're assuming multiple inheritance on the object side as well. So this would seem to say that you should be granted permission. Similarly, I've got this path. I'm a member of this group. This group is a member of that group. This group has the permission on this object. This is a piece of that object. This is a piece of that object. And so again, I should be granted permission. And finally, I am a member of this group. This group is a member of this group. And for this group, I didn't say whether or not you've got permission on the object. So do I take as the default you are allowed to or you're not allowed to? What we have to do is somehow take all of these things and come together with a policy, which I'll call a conflict resolution policy, that will resolve all of these things and let you know at the end whether you've got permission. And what the point of this exercise is that I can encode my conflict resolution policy and deploy my system with a different conflict resolution policy for every installation, depending on what the rules are that you want to have running at your installation. So we can make different rules for different people, but I can write one piece of software that can determine whether or not you have permission, regardless of what rules you pick. So here are the considerations that you have to keep in mind. You have to somehow worry about the paths that go up and eventually reach a node where there are no permissions anywhere along that path. What are we going to do if I reach such a node? We have to worry about conflicting permissions on the same path. So as I go up the path, I get to some node that says I have permission, but if I go further up the path, I get to another node that says I don't have the permission. Who wins? Third thing I have to worry about is two different paths. I go up this path and I come to a node that says I have permission. I go up this path and I come to a node that says I don't have permission. What do I do? And there are lots of standard conflict resolution policies that have been proposed. There are the open and closed policies. So by default, everybody has permission, or by default, everybody does not have permission. That would tend to address the first of these. I have permit or deny overrides. So if I have two different paths, and one of the paths says you do have permission, and one of the paths says you don't have permission, as if there's any path that says you don't, then you don't. That's permit. That's deny overrides. Otherwise, you could have permit overrides. I could have a first privilege applicable, so I have some way of enumerating my permissions in some order, and the first one I come to in that order. If it's a permit, you're allowed to do it, and if it's a deny, you're not. I can have majority rules, count up how many permissions have been granted, how many denials have been made, and whoever has the more, that's what I could use. I can have some sort of stratified privileges. So it's been proposed that we could have two different kinds of permissions, for example, strong permissions and weak permissions, and strong always overrides weak. And if you have two strong that conflict, that's just an error. And if you've got two weaks that conflict, I think that's also an error if there's nothing to resolve the problem. Or I could just say conflicts are not permitted at all. I sort of, as soon as I come to this sort of a situation, I just say, forget it. You're not allowed to have a conflict. I'm not going to, it's an error. We have to reconfigure the access control. So let's now look at a single path. So I've got the subject, the object or subject that I'm interested in. On the path going up, I have a P2 has either positive, there's either a positive or negative permission P2, and if I go up some a little higher in the path, P1 has some other permission. Three ways that I could deal with this situation that I can encode in my policy. One is the higher privilege overrides the lower one. So company policy trumps whatever anybody in the company wants to say. If the company says you do have permission on this, then nobody is allowed to say you're not, or the other way around. And so if this is the case, then I could record at the subject level or object level, I could record that whatever the permission one is, positive permission, let's say you are allowed to do it, is at distance 2 from me, 2 up the chain, because I might want to use distance later on to do some conflict resolution. Depends, sort of, I might want to take the closer one to me as the dominant one. So I will record that permission 1, in this case, if I have overrides, then permission 1, whatever that was, is the permission that I'm supposed to be thinking about. I can also, instead of that, have that the lower privilege blocks the higher privilege, which I think is the more common interpretation of these hierarchies. So if a group has positive permission and a member of that group has the negative permission, then I am saying everybody in the group is allowed to access this object, but not this particular member or not this particular subgroup. That's usually the way that this is set up, or the group is denied, but this particular subgroup is given permission. Okay, so the lower one in the path is the one that blocks the higher level permissions in some way. And so if I'm using blocking rather than override, then the permission that comes through is that P2, whatever it was, whether it was positive or negative, I've got the P2 permission at distance 1 from me. And the third possibility is that I actually preserve both of them, and I'll make up the resolution later. For the time being, I'm going to have the fact that I'm going to record that for this particular subject or this particular object in the hierarchy, that I have 2 permissions, both P1 at distance 2 and P2 at distance 1, and I'll worry later. So it's just as if they came down 2 different paths. I don't distinguish between coming down one path and coming down 2 different paths to me. Okay, so here is now, with that in mind, that I have these 3 different kinds of ways to deal with paths on permissions on a single path: override, blocking, and preserving both. Then I can have this kind of a setup, and I will introduce one more kind of permission. I will remember that there's a default permission, whatever that is. So at this node, because as I go up the hierarchy, there's no positive or negative permission, I just record I have a default permission at this node. Taking a look at this particular object, for example, I see that I have a negative permission at height 1. That's this one. And I'll record the distance in both hierarchies. So distance of height 1 in the subject hierarchy, distance of height 1 in the object hierarchy. I've got a positive at 1 and 1. I've got a positive at 2, 2. And I've got a default at 2. Those are all of the permissions, the explicit permissions, plus the default, that might affect me. If I have the override policy, then only these 3 permissions apply. The negative at 1, 1 doesn't come into the picture, it was overridden. If I have the block policy, then the first one, the plus at 2, 2, doesn't come down to me, it got blocked. This 2, got blocked by this negative permission in between. So I'm only taking the closest one on a single path. So in the blocked, I'm going to have these 3 permissions to contend with. And if I have the pass-through, then I've got these all 4 permissions to contend with. Okay, so depending on how we deal with single paths, I can collect together a set of explicit policies and explicit permissions or denials, and how far away they are from where I am. And now I'm going to take this set, this resulting set, and apply my conflict resolution rules to that, further conflict resolution rules. We've started already with override and blocking, taking some of the conflicts out, but now we're going to take out the rest of the conflicts. It turns out that this kind of a graph captures a large collection of possible conflict resolution policies. Do I take into account a default when I am doing my conflict resolution? And if so, is the default permit or deny? Do I take into account the distance from the particular subject or the particular object where that permission is initiated? If so, locality, then I might take the global one preferred, the one that's furthest away, or I might take the local one into account, the one that's closest to me. If I have some number of positive permissions and some number of negative permissions, I can choose to take the majority, who has more. And that's really the only one that makes sense. It doesn't make sense. I don't know of any situations where you would say, I'm going to pick the minority, the fewer ones. It just doesn't seem to make sense to me. And finally, if I have a preference at the end, so if I have not been able to resolve through one of the previous methods, then I can either permit if there's at least one yes, or deny if there's at least one no, or always permit or always deny. And the idea of this graph over here is to indicate all of the different policies that you can have. These, default, locality, majority, are all optional, so you can leave them out or you can use them. You must have preference as in your policy. And the order can be default preference or default locality preference or default locality majority preference. And what I mean by this graph is that this is the order in which you're going to try to make a decision. If, for example, let's take this particular situation, I am going to use blocking on a single path. But after I use blocking on a single path, I am then going to take the resulting group and I'm going to assign negative permission to all of the defaults. So by default, it's negative. And then after that, I'm going to assign, in the preferences, I'm going to assign negative. So if you haven't made up your mind, by the time you get down to the end, if it's not just a positive, but you actually have something else and you haven't resolved the conflict yet, you're going to choose negative, deny. I might also instead consider the pass-through group, and I might say the first thing we're going to do is count how many positives versus how many negatives. Notice in this case, default don't count. So that's why I didn't mark them as positive or negative yet. I know which are the positives, which are the negatives, which are the defaults. So if the default doesn't count, I don't want to take those into account. Just look at explicitly how many positives there are, explicitly how many negatives there are. Majority with rules. If it turns out that they're the same number of positives as negatives, then we go to the next step to try to resolve it further. So we first try to resolve it by majority. If that comes with a tie, we go on to look at the preference. I'm going to prefer plus. So whenever there's a tie, I'm going to pick plus. Third one, I'm going to say, I'm going to pick the furthest away privilege. If the furthest away thing says you're granted, I'm going to give it to you. If the furthest away thing says deny, I'm going to deny it. In case of a tie, there are two opposite privileges equally far away. I'm going to go on to the next step, which is again, in this case, just the preference. And I'm going to deny. Or maybe I'm going to use blocking and I'm going to take the closest one. But if the closest positive is equal distance to the closest negative, I've got to go on to the next step and resolve it. Or maybe I'm just going to use blocking and then I'm not going to at all determine how many privileges there are, or how far away there are, but I'm going to give you permit if anybody says yes and otherwise deny. Okay? Now this graph says what you can put together. So I can first of all assign my default or not. Then I can choose to take into account locality, how far away it is. And if that resolves it, I'm done. If not, I go on to majority. If that resolves it, I'm done. If not, I go on to preference. Or I can take this other path and say I'm going to go to default, and then I'm going to go to majority, and then I'm going to go to preference. Any one of these paths through here gives you a policy together with dictating what we're going to do on this path. So I can write policies using these kinds of abbreviated notation. Okay, so here is then an example of the conflict resolution policy. Again, I'm using the same example. Here's the override and blocks and pass-through. And here's the policy. The claim is if I take default as negative, and then I use the preference negative, then because I have some things that are negative, I'm always going to choose negative. It's only if everybody was positive would I give you a positive permission. The next one, if you work through it, would come out that we're going to grant permission in this case. The next one, and we can go through this. Okay, so what's the point here? The point is I can record the policy that I have. I can do the algorithm that calculates the set of permissions. I can now run through that policy and make my decision. Okay? And I can, from installation to installation, I can change. On your installation, we'll use D minus P minus. On this other installation, we'll use L P minus. And the same software could work out policy. So let's summarize. My claim is it's feasible to create one code base that can be adapted to the enterprise security needs at deployment time or later, that we can perhaps update it if we want. We use creation time policy to initialize the explicit permissions. We use a conflict resolution policy to establish the effective permissions, and they will always end up with either a yes or a no, because you have to have a preference. You're not allowed to leave preference off your policy, so eventually it has to get resolved. And the current privileges are used to determine the rights to manipulate all objects, including the subjects, including the permissions themselves. And because this is just using a group hierarchy, you could use the same ideas in an RBAC kind of model as well, where the RBAC hierarchy plays the same kind of role as the group hierarchy. So we could use the same kind of approach there. So that's all I wanted to say. And I'll stop at that point.
Okay, thank you. And are there questions? Yeah. Okay, you needed to speak into the microphone.
Can you explain how the system would work with something like the Bella-Padilla model, where you have the different clearance levels for the subjects, and then the objects would have different security levels? If the subject at the bottom is able to, I guess, through covert channel or something, get to an object that's at the top security level, they can taint it then by modifying it through permissions, right?
Okay.
Right permissions.
So a good question. The question is about the Bell-Padilla model, and that's an example of a mandatory access control system, whereas I was talking about the discretionary access control system. And the discretionary access control system, it's based on the fact that individuals are allowed to to grant and deny privileges to others, and that we have these, I've applied it now to these hierarchical situations. This whole discussion doesn't really apply to the mandatory access control models, because we don't have that capability of passing permissions around, which is what I was trying to capture here.
Other questions? Yeah, perhaps if there are no other questions. Okay, first of all, this was really a good question, but again, as Professor Tompa mentioned, mandatory access control, they use a different approach to decide when somebody can access an object. I have a question though. Sometimes in looking about conflicts, a way to solve the conflict may be to look at the grantor of the authorization. Because sometimes, okay, suppose you have a project, you have the manager of the project, then you have two associate managers. Now, the two associate managers can say, oh, this employee can read this sensitive document. The other one may say, no, he cannot read. Mm-hmm. So in that case, perhaps their boss may take the decision. So would that be possible to be done in your...
Okay.
Yeah, you need to look at the grantor.
So
right?
can we? So the model that I was proposing only looks at the static snapshots of what is currently allowed, and I don't have the history of who granted what to whom.
Yeah.
So we'd first of all have to somehow extend the model to include grantors, and then try to figure out how to write the policies that would include those.
Yeah.
I mean, I think it would be possible to do such extensions. I haven't thought about how to do the extension. The model itself would somehow have to keep track of some more information that it currently has.
Actually, if you look at this is a very good point. Exactly, you needed to keep track of that. And if you look at the discretionary access control for database system, like the SystemR model, it keeps track of the grantor.
It does.
Yeah.
It does.
But so far, no one has really thought how to solve conflict, also looking at the grantor, based on the grantor. Because some subjects maybe have more authority than others.
Yeah.
So what they say this is allowed may prevail over other grantors.
Yeah, I think that forms an interesting question.
Yeah.
So, I mean, in the in a model that Amir Shinai had put together, there was a middle layer that I left out here, which was a hierarchy that kept track of who granted permissions to whom. But I don't think that we extended so that would be the first thing I would do, is put that back in again. So now I have a model that captures the hierarchy of granting as well as the original. Why is it a hierarchy of granting? It's not only because some people have more authority than others, but I might want to know, was I an initial person who got the permission and then granted it to you, and you granted it to that person, or did I grant it directly?
Yeah.
So again, I might be interested in this hierarchy of granting going on. And then once that's in the model, then I can imagine that there'd be some way now to encode as part of the decision-making process.
And I have a question, because I think this is an interesting direction, but sometimes this brings the fact that somebody will have to configure the system. So you can see, as specifying those policies, configuring the access control system.
Exactly.
So have you developed some easy-to-use interface which users can click and...
for configuring this?
Yeah, because it becomes a bit complete, or they can provide examples, say, this is what I want the system to do.
Yes. A very good question. Sort of how do we... So this is sort of, if you wish, a theoretical look at how you could have such a system. Now, if you built such a system, how do you teach your customers how to use the system? What does the manual look like for how to use this system to get the right kind of effect that you want at the other end? I think is a very good question. We're only just starting to think about that possibility. The first question that I would ask of you is, If I have if I have a system that only supports one kind of conflict resolution policy, how do I configure my explicit permissions and denials so that in that conflict resolution policy, the right thing happens? Where do I put the permits? Where do I put the denies if all I'm allowed is blocking with majority first and then locality and then default is permit?
That's an excellent comment.
And if I have that, how do I, and now you move to a system that only has a different conflict resolution policy. How do I take my existing configuration and shift it over to my other system? So I use, person X, company X has sold me their brilliant system that uses access control in method one, but company Y sort of has many more features, and so I want to go to company Y's system, and they also have a good access control system, but how do I translate what I was doing over there into the other system? That, I think, forms an interesting problem.
Yeah. Just as a comment for you, remember in security, usability is very important because a lot of security problems arise because certain features are difficult to use. So users may do a lot of misconfiguration. As a result, attackers can exploit them and get into the system. Mm-hmm. Okay, so if there are no more questions, there is another question. Then,
I have a question about your subject and object hierarchies. Throughout the presentation, you talked about the subjects more as users than as, say, processes in our traditional operating system environment. And I wondered how you might distinguish in that hierarchy between possibly user accounts and processes, or if we might need another hierarchy and another more complicated set of permission calculus.
I was not distinguishing those. My view was that when either the subject signs on or when the process gets initiated, the process or subject, the human or the process, gets assigned by the authorization mechanism to some of these groups.
So there might be some extra authorization authority that would involve averting the problem of ambient authority such that the process does something that the user didn't intend. Yeah. Or not that the user didn't intend, but that is actually illegal if you think about it.
That's right. So my suggestion would be that the process would be associated with one or more of these groups based on some authentication mechanism or authorization passing mechanism. And then once the process is in these groups, it is bound by the same rules that says you are allowed to do this, you're not allowed to do this. So if the process tries to do something that's illegal, it would immediately be barred from doing it, just like the human would be barred from doing it. So I wasn't really distinguishing those, and I think it's the equivalent. So for a human, you get authenticated, and that somehow gets you started, or you start your session, and that gets you assigned to certain groups. And I would think that when a process gets started, that again, a mechanism would be in place that would assign it to the groups. And I wasn't worrying about that authentication mechanism at all. I think that it's related to that.
But this is an excellent question. Add just a short comment. Typically, if you have roles which you can see a little bit like groups, then the user has to specify which roles the user wants to use. And therefore, the process will have only those roles and only those authorizations. But the distinction between user and subject is very important. So actually, with Professor Lee, we write a proposal where we will be investigating exactly this problem. No, because now if somebody connects to a subject, like a process, we don't want the subject to have all the authorizations of the user, because that is the serious problem in security. But the question is, which one should those permissions be? How do we do that? That's exactly one problem, the distinction between... But now this is orthogonal, because This may happen even if those are processes. Once they get all those different permissions, that they are inherited from the groups to which the user, on behalf of whom the process has been initiated, belongs to. Even though you may exclude some groups, but you will have still conflict.
Yeah.
I think that's a very important
And as
topic.
processes fire up other processes,
Yeah.
they also have to get somehow assigned to some particular
authorizations.
groups.
In security, one serious problem is try to avoid that processes acquire too many authorizations. You try to confine them because otherwise, this is called escalation of privileges when they start having a lot of them. That's what you don't want. Well, I think this was an interesting talk, and let's thank you. Also, thank you for all the good questions you made today. I hope you now will go back and have a good opinion of our students.
Absolutely. Yeah.
They're smart. Thank you.
Thank you. Thank you for your attention.